Good morning, dear students. Today we are going to learn class 12 commerce subject statistics chapter number 2 random variable and discrete probability distribution. 2.3 binomial probability distribution. In the earlier section we considered continuous and discrete random variable and a probability distribution of a discrete random variable. Now we shall study an important probability distribution of a discrete random variable. In some random experiments, there are only two outcomes. We call such outcomes as success and failure. Okay. These outcomes are mutually exclusive. We call such experiments as dichotomous experiment. It's a very important. Dichotomous experiments, it means there are only two outcomes. Okay, suppose it is success or failure, or true or false, yes or no. It means there are only two outcomes. Okay, it is called dichotomous experiments. Here given that illustration of some of these situations are given in the table below. Okay, so here first experiment and second possible outcomes, success and failure is given. See, so in first, to know effect of advertisement given to increase the sale of a product units. Okay, sale increased is success and sale did not increase is the failure. So there are only two outcomes. Okay, and this type of outcomes is called dichotomous experiments. Is it clear? Second, to find the error in letter typed by typewriter. Okay, success is error observed, otherwise you can't observe, error not observed, so it's the failure. So only two outcomes. Third, to know the effect of a drug on blood pressure given to patients of high blood pressure. So success is blood pressure decreased, या तो blood pressure did not decrease, sorry. And fourth one, to inspect whether produced item is defective. So success is items is defective and failure is item is not defective. Is it clear? So here in given table all experiments are called dichotomous experiment because there are only two outcomes, success and failure. We denote the success by S. See, keep in mind, we denote success by S and failure by F for such types of dichotomous experiment, and the probabilities of such outcomes by small p and small q respectively. It means success is p and failure is q. And one more thing, the value of p and q is must less than in 0 to 1 and p plus q equals to 1. See, success, probability of success plus probability of failure is always 1. Okay, is it clear? Now see, since there are only two outcomes of such experiment and both are mutually exclusive, we have p plus q equals to 1, yes or no? And hence q equal to, we can write 1 minus p. If it is possible to repeat such a dichotomous random experiment n times and each repetition is done under identical conditions, then the probability of success p remains constant in each trial. We call such experiments as Bernoulli trials. Its actual definition can be given as below. Okay, so here Bernoulli trials given. Suppose the dichotomous random experiment has two outcomes, success S and failure F. If this experiment is repeated n times under identical conditions, it means whenever we have to given more than 2 or 3 numbers, then we have to use this trial, and the probability p is 0 less than p less than 1 of getting success at each trial is constant, then such trials are called Bernoulli trials. Properties of Bernoulli trials. Okay, so the probability of getting a success at each Bernoulli trials remain constant. First one. Second, Bernoulli trials are mutually independent. That means getting success or failure at any trial does not depend on getting success or failure at the previous trial. And third one is success and failure are mutually exclusive and exhaustive events. Therefore, we can write Q is equals to 1 minus P, because probability of success plus probability of failure, P plus Q equals to 1. Is it clear? Now, see, we have to discuss about binomial probability distribution, BPD. Okay, it's important one. See, suppose X denotes the number of successes in a sequence of a success S and failure F obtained in n Bernoulli trials. Then X is called random variable, and X assume any value in the finite set 0 to n. The probability distribution of the binomial random variable X is defined by the following formula. It's a very important formula. See, P of X equals to X is equals to P of X is equals to NCX is the combination NCX P raised to the power X, it means success raised to power X, Q raised to power n minus X, it means failure raised to n minus X. The value of X is in between 0 to n, and the value of P is in between 0 and 1, and Q equal to 1 minus P. So in this example, P or Q is given, and find Q or P from one failure or success. This probability distribution is called a binomial probability distribution. We shall call such a distribution in short as binomial distribution. If positive integer n and a probability of success P are known here, the whole probability distribution, that means the probability of each possible value of X, can be determined. Hence, n and P are called parameter of the binomial distribution. Important one. Okay. N and P are parameter of binomial distribution. Is it clear? We denote a binomial distribution having parameters n and p as B means binomial probability distribution bracket n comma p. Okay, is it clear? Now see, one note: if we repeat an experiment having such a Bernoulli trials capital N times, and P of X is the probability of getting X successes in the experiment, then expected frequency number of success in capital N repetition is capital N into probability of X, it means P of X. Now we have to discuss about properties of binomial distribution. Okay, see, first, binomial distribution is a discrete distribution. Okay, first. Second, its parameters are n and p. Is already we have to denote B bracket n comma p. Yes or no? Third, the mean of distribution is np. Okay, so third one is mean is equals to np. Fourth, variance of the distribution is npq and standard deviation is under root npq. Fifth, for binomial distribution, mean is always greater than the variance, and variance upon mean equal to q. Okay, whenever variance and mean is given, okay, so we can find q or p from variance and mean easily. Now see, property number 6, 7 and 8, it's very important. Okay, 6, 7 and 8 we have to understand from given below graph. See, so here graph is given. Okay, so see, 6 number, if p is less than 1 by 2, if p is less than 1 by 2, then the skewness of the distribution is positive. Okay, see here, in first case, the value of p is less than 1 by 2, it means less than 0.5, so skewness of distribution is positive. Okay, second, if the value of p is equal to 1 by 2, then the distribution becomes symmetric. That means the skewness of distribution is 0. Okay, in second case the value of p is exactly 1 by 2 or 0.5. So in this case skewness of distribution is 0. And in third case the value of p is greater than 1 by 2, it means greater than 0.5, then the skewness of the distribution is negative. Okay, for any value of n. Now we have to see the graph so we can understand easily. See here the value of p is less than 1 by 2, so positively skewed binomial distribution. Here the value of p is exactly 1 by 2, it means exactly 0.5, so the graph is 0. And for the value of p is greater than 1 by 2 or greater than 0.5, so our graph is negatively skewed binomial distribution. Is it clear? So thank you so much all of you. If you like this video, okay, then share and subscribe.